Alright, I'm Jordan Anderson again, and I've managed to pull myself away from Dragon Age Origins and my obscenely loud metal to talk about sine and cosine functions. Now, these are very important functions in all kinds of math, almost all kinds of math, and there are actually a lot of real-world applications for this one. They can help you find the distances if you only have They can help you find distances if you have other distances that relate to them. They can help you find the angle at which something was projected through the air. Lots of cool stuff, and especially in physics. So, something really important for sine and cosine functions are trigonometric ratios. No idea how to pronounce that, and I realize that my handwriting is worse than a second grader's. So, what these are talking about is a triangle that's made out of an angle, which sounds kind of confusing, but is actually pretty simple. So, say you just have an angle, and what you do is you draw a perpendicular line, or a line perpendicular to the x-axis, to that angle, and it gives you a right triangle. Now, let's say this is A, this is side B, and we'll call the hypotenuse C. Now, cosine it's a ratio. So cosine is equal to the adjacent side over the hypotenuse, which in this case would be equal to A over C. For sine, it's the opposite side over the hypotenuse. So, opposite over hypotenuse, which is equal in this case to B over C. So, these are very important because then, using a calculator, you can calculate the sine of, say we have a 40-degree angle here. So you could calculate with the calculator the sine of 40 degrees, and it gives you a decimal, usually, unless sometimes if you're using tangent, you can get a number greater than 1, but we'll talk about that in another lesson. So, the decimal, then say we know the value of C. We'll say it's 4. This is probably not going to work out to be a real triangle, but for example's sake, it'll work. So, you can take the decimal 0.643 times 4, and it'll give you 2.57, which would turn out to be B. This works because we have, just think about it. So, we're saying we know the hypotenuse is 4, so sine of theta, the angle in question, equals 4, equals something over 4b. So if we multiply both sides by 4, it'll give you b. Alright, so in using that, it really helps out when you have some information for a triangle made out of an angle, but not all of it. So basically, if you have two measurements of almost any, regardless of which one in most cases, you can find every measurement in the triangle through math. So, and there's also lots of other important stuff to do with sine and cosine. First of all, when you're graphing them, for instance, we'll say y equals sine of theta. Now, textbooks tend to give you a really, really unnecessarily complicated explanation of what this makes, which is called a periodic function. But basically, it's a function that when you graph it, it just repeats itself. So, it would be something like this. See, right here, and right here, it repeats the exact same thing, making it a periodic function. And in another lesson, we'll get more into how to write periodic graphs and cosine and sine functions. And yeah, they're a lot more simple than they look. So, there are also relationships between sine and cosine. Before we do that, I'm going to show you how you can tell initially whether the sine of a certain angle or the cosine angle will be positive or negative. So, in this kind of math, the hypotenuses, or the initial ray you have making the angle, is always considered positive. So even if it's over here in the negative where it might be considered negative, at a glance, it's still considered a positive measurement. So, we draw the perpendicular line, but in this case, this would be a negative measurement because it's going straight down, which means it would be a negative y value. So, we'll call this negative b, a, and c. So, the sign of this one would be negative b over c. So, clearly, you would end up with a negative number as your answer because you're dividing a negative by a positive. Now, the same principle applies for the rest of the measurements, but an easy way to tell is thinking of cosines in terms of x values because they're measuring the adjacent. So, for cosine, if the angle is over here, you're going to have a negative value here. And the same thing if it's in this quadrant, because this will still be negative. For sine, it's going to be positive if it's in either of the top two quadrants, quadrants 1 or 2, but it will be negative in either quadrant 3 or 4, because this value will be negative. So, now that that's clear, there are also some relationships between sine and cosine values. Specifically complementary angles. So, say you have an angle over here. We'll say this is 30, and this whole angle here is 150. Now, if you take the cosine, if you take the cosine of 150 degrees, it gives you negative point, it gives you negative 0.866. If you take the cosine of 30 degrees, it gives you 0.886. Forgot to write in 150. So, now, for sine, well, this is true because this is a positive value for cosine and this is a negative value for cosine. Say we've taken the 30 degrees right there, so that would be 330 degrees. This would still be positive, so cosine of 330 degrees is the same as cosine of 150 because you're still taking the same size angle but at a different position. So basically, the cosine of an angle and the cosine of an angle that's complementary to that, if one is positive and one, you can tell because this is a negative value and this is a positive value. I explained that very badly the first time, but I think you get the general idea now. So, for sine, it's a little different. Because, as I explained earlier, the relationships are different. So in this quadrant, sine will still be positive, and in this quadrant last time, the cosine would have been negative. So, you take the angle 150 degrees. This time, they're equal. Sine of 150 degrees and sine of 30 degrees both equal 0.5. Alright, now, I believe that's all you need to know for this section, but we'll be going into more detail on this later. And it's also unbearably hot in my house because the AC is broken, so I'm going to wrap things up there and probably go play video games for 4 hours.